A solid cylinder of mass 250 gram and radius 4 centimeter is rolling down an inclined plane. The angle of inclination is theta is equal to sin inverse 1 by 10. The total kinetic energy of the system after 5 seconds will be equal to. If I take this as an inclined plane and this angle over here is equal to theta, a body is rolling down an inclined plane, okay, and we have to find out the velocity after 5 seconds, okay. First of all, the acceleration of the rolling body is given as g sin theta divided by 1 plus k square by r square for pure rolling motion. So basically g sin theta is equal to 10, okay, g over here is equal to 10, sin theta, theta over here is equal to sin inverse 1 by 10. So sin theta will be equal to 1 by 10. Since it is a solid cylinder, k will be equal to r by root 2. K will be equal to r by root 2, so k square will be equal to r square divided by 2. So basically it will be equal to 1 by 1 by 2. So basically it will be equal to 1 into this 2 will go in the numerator. So basically it will be equal to 2 divided by 3. This is the acceleration of the body. In order to get the angular acceleration will be equal to tangential acceleration divided by radius, which is equal to 2 by 3 into radius. Radius over here is given as 4 centimeter, which is equal to 4 into 10 raised to minus 2. Okay. So this is the angular acceleration, which is equal to 1 by 6 into 10 raised to minus 2. We have to find out the final angular velocity. Initial angular velocity, since it is not specified, I will assume it to be 0. Okay. Initial angular velocity, since it is not specified, I will assume it to be 0. Final angular velocity, in order to get the final angular velocity, omega 2 will be equal to omega 1 plus alpha t. So omega 2 is unknown, omega 1 is 0, alpha over here is equal to 1 by 6 into 10 raised to minus 3 minus 2 into over here time over here is given as 5 seconds. Okay. So this can be written as 1 by 12 into, I have multiplied divided by 2. So it will be equal to 10 raised to minus 3. This is the omega 2. Okay. Let this be equation number 1. Let this be 1. Okay. Now over here we have to get the total kinetic energy. Total kinetic energy at the bottommost part will be equal to half mv square 1 plus k square by r square. 1 plus k square by r square. So v over here can be written as half m omega square r square into 1 plus k square by r square. So basically when I substitute the values over here, it will be equal to half. The mass is given as 250 gram, which is equal to 0.25 omega square. Omega square will be the square of this part, 1 by 12 into 10 raised to minus 3 the whole square, or 10 raised to minus 3 is also in the denominator. Okay, 10 raised to minus 3 the whole square into r square. R over here is equal to 4 centimeter, which is equal to 4 into 10 raised to minus 2 the whole square. 1 plus k square by r square is equal to 3 by 2, as we have established up. Okay, now 0.25 can be written as 1 by 4. This will be equal to 1 by 8 into 1 by 12 into 12. This will be, when the 10 raised to minus 3 goes in the numerator, it will be equal to 10 raised to 3, and when it is squared, it will be equal to 10 raised to 6 into, it will be equal to 16 into 10 raised to minus 4 into, over here it will be equal to 3 by 2. So basically let us see what are the terms we can cancel out. 8 and 2 will cancel out the 16, 3 will cancel out over here, it will become 4. So basically it will be equal to 10 raised to 6 and 10 raised to minus 4 will be equal to 10 raised to 2, which is equal to 100. 100 divided by 12 into 4 will be equal to 48. So if I roughly treat the 48 as 50, approximately we will get the answer as 2 joules, which is over here approximately we will get the answer as 2 joules, which is option number C.